Okay. Thank you, Evan. Always a pleasure to be here at Meta. You know that because I do it so often. Um, let's start sharing here. All right. So, let me get things cleaned up. Uh, hmm. Somehow, um, can you see my slide anymore? Because I can't.
Yep.
I
I
think I
see.
knocked off something. So just give me a minute to figure out how to recover here. Um, That's not it. Oh, here it is. Okay. Now I can see what I'm talking about. Okay. Okay. Yes, I'm Bob Kleinberg, and a good day. I'm speaking to you from Cambridge, Massachusetts. Nice and hot here. Evidence of climate change in action, you might say. Um, Always a pleasure to be speaking at the Methane Emissions Technology Alliance. And my topic this time round is problems with greenhouse gas life cycle analyses of U.S. liquefied natural gas exports and locally produced coal. And as you'll see in just a minute, this is a pretty hot topic and very timely. So let's get started. Okay, next. Here we go. I think I skipped one previous. Okay, I'm going to start with this article in the New Yorker magazine, which sort of kicked off this whole story. Um, I do subscribe to the New Yorker, but I can't say it is my usual source of information about petroleum engineering or atmospheric chemistry. Nonetheless, they did manage to sneak this article in that is pretty relevant to our concerns. The title is A Smoking Gun for Biden's Big Climate Decision. A new analysis suggests that LNG, liquefied natural gas, exports may well be worse for the environment than burning coal. It was written by Bill McKibben, well-known environmental activist, and attracted a lot of attention outside of our circle. So, what is the big climate decision and what's the smoking gun? So the big climate decision basically is the public interest determination mandated by the Natural Gas Act of 1938. I'm just going to quote from the act here. No person shall export any natural gas from the United States to a foreign country without first having secured an order of the Commission authorizing it to do so. The Commission shall issue such order upon application unless it finds that the proposed exportation will not be consistent with the public interest. I apologize for the double negatives. The commission here is the Federal Power Commission, which no longer exists. Its powers were transferred to the Secretary of Energy. And on January 26th, the Department of Energy announced it was updating its public interest analysis and pausing permitting of facilities allowed to export LNG while this update is underway. This sort of made it into the newspapers for like a day, but it had really rocked the industry because it is a really big deal. Um, how big a deal is it? Okay. So the US started exporting natural gas via liquefied natural gas in tankers in 2016. I mean, at scale, I think there was a small project before that. Um, and it's built up remarkably fast. So as of now, we're exporting 11 billion cubic feet of natural gas per day. That's something like 10% of our total um, production. And we are now the world's largest exporter of liquefied natural gas, having surpassed both Australia and Qatar. And that's what's online now. So online now, 11 BCF per day. Under construction, We've got we're doubling that again to something like 24 BCF per day. And that's projects both in the United States and projects in Canada and Mexico through which U.S. natural gas will be exported and therefore comes under the authority of US DOE. So by 2027, we are going to be set up and have the facilities to export 24 BCF a day, which is about a quarter of our total production. So, like I say, a big deal. And the Department of Energy has found for all these projects that you see listed on the right side here, that they all satisfy the natural interest determination. And originally, the public interest determination was revolved around the price of gas and the availability of gas. These days, environmental issues have been, attached to that, and so greenhouse gas emissions are a big deal. DOE, again, has been permitting these things pretty freely. I mean, the industry complains they're too slow, but in fact, these permits have been moving right along. Okay, so none of that is affected by this DOE permitting pause I just told you about. All that is in the works and has already been permitted. What's still in the waiting list is 11 projects. Doesn't sound like much, but those 11 projects comprise 192 million metric tons of LNG per year, which is another 25 BCF per day. So again, we're going to double again our export industry with a projected capex of $100 billion for these 11 projects. So that's what I meant when I said this is a big deal. It's a big deal in terms of the economy of the Gulf Coast. It's a big deal for the countries that are eager to import gas at lowest possible price and therefore ready availability and so on. So this is a $100 billion decision that Biden's going to be making, or who's ever president when it finally gets made. Now, our leadership in the U.S. House of Representatives is particularly interested in this LNG permitting issue. Mike Johnson, who's the Speaker of the House of Representatives, represents Shreveport, Louisiana, which is right in the middle of Haynesville, the Haynesville Basin, which is the prime Tiffany export origin for gas going to our biggest customer, which is Europe. Europe has recently passed law which is going to mandate, it's pretty clear where they're headed. They're going to mandate fossil fuel imports with the lowest possible greenhouse gas impact and footprint. And if you want really clean gas that has had very little methane emissions, you go to Haynesville because dry gas, no oil, no separators. That's the good stuff. So Mike Johnson, really interested. Garrett Graves was the ranking member of the House Climate Committee, represents Baton Rouge, Louisiana, which again is also in the middle of this whole LNG export business. So lots and lots of political muscle here, very interested in what's going to be happening with DOE. Okay, so what is the smoking gun? So on the left here, I have a two-part chart. I'm going to talk about the left-hand side of that chart first. So what we have on the vertical axis is grams of CO2 equivalent per megajoule of electrical energy output of a fossil fuel electric power plant in Shanghai, China. And you can see it's about 300 grams of CO2 per megajoule of electrical energy output. The black bars are power plant CO2 emissions. And you can see that for coal, it's more than twice as much as for liquefied natural gas. I mean, we know that when coal is burned, it gives off a lot of CO2, natural gas, a lot less. So that's the black bars. That's easy to understand. The other colors represent supply chain emissions. So for example, you have supply chain CO2 emissions because you have a liquefaction step with the LNG, which costs energy and therefore produces CO2 when the energy is used to do the liquefaction. And you have methane, which, as we know, is from upstream operations. I think this audience knows this extremely well. So we have some methane emissions. And together, they add up to a significant increment of additional greenhouse gas as measured by CO2 equivalent. But still, looks like LNG is a lot better than Chinese coal. So therefore, the DOE was very happy to use this assessment and the ones that preceded it from the National Energy Technology Lab to say, okay, it passes the environmental test for climate change. And everyone's happy. So that happy situation was sort of kind of damaged, I would say, with this study that just came out late last year and then continuing into this year by Professor Robert Howarth at Cornell University. Howarth is well known for being in the keep it in the ground faction of the kind of fossil fuels skeptics. He's been sort of campaigning against hydraulic fracturing for the last 15 years. And so he's come out with this new paper on LNG exports. And he comes up with a very, very different result. Again, color scheme is the same on the right here. And he finds that there's a higher greenhouse gas impact from LNG exports than from burning domestic Chinese coal. Again, the black bars, again, the coal is higher, obviously, because again, in the power plants, coal just gives out more CO2 than natural gas, no question about that. But then he shows or claims the upstream emissions, particularly of methane, kind of overwhelm that advantage that LNG has in the power plant. Now, I do want to warn you that the vertical axis on the right side is different than the vertical axis on the left side. This is one of the more delightful aspects of this whole investigation. On the right side, we have grams of CO2 equivalent emission. Okay, fine. Divided by, but the energy denominator is the megajoules of thermal energy at the input of that electric power plant. So left side is megajoules of electrical energy at the output of the power plant. Right side is megajoules of thermal energy at the input of the power plant. And the difference is that it's a little complicated here. The coal burning power plants are less efficient than the gas burning power plants. So, and I'll show you in a minute exactly what effect that has on the results, but it is pretty subtle. I don't even bother going into this for the policy audiences, believe me. But I will try to sort of walk you through it. But anyway, the net result here is that Howarth claims on, I would say, pretty reasonable evidence, and I went through all the numbers, and his numbers are generally not crazy, that LNG has a higher greenhouse gas impact than coal. So if so, and he proposes this in his paper, he says we should not be building any more LNG export facilities. We should just let the Chinese burn the coal. Okay. So which of these life cycle analyses is correct? Must be bad internet on my end. Oh my gosh. Am I not coming through? Let me.
You're loud and clear, Bob.
So I'm okay here. Everybody else can hear me?
Yep.
Okay, it seems that just Elise is having a problem. Okay. Okay, let's go back. Moving on. But if I do cut out, please let me know. Okay, so this smoking gun that was announced by the New Yorker magazine seems to have propagated into the White House. So in February, Aaron Clark, who is, ace reporter at Bloomberg, had this really interesting article He said that when the Biden administration paused approval of new liquefied natural gas export licenses in January, the decision was driven by a recognition that the climate impact from fossil fuels needs to be reassessed. The fight over just how much LNG contributes to global warming was rekindled in part by a study with explosive findings compiled by Robert Warren Howarth, a professor at Cornell. The analysis finds the total greenhouse gas emissions from US LNG in the best case scenario are comparable to coal. In the worst case, emissions could be more than twofold greater. So that's some pretty good reporting from Aaron Clark. So this Howarth paper has had a big influence and basically stopped DOE approvals of these permits while they are trying to figure out who's right. So I'm going to try to help them. Okay. So I went through these two papers pretty carefully and very carefully, actually. And so there's a number of factors you have to look at as described on this slide. So the first is current methane emissions. So that's methane loss from wellhead to burner tip divided by methane arriving at burner tip. So that's pretty straightforward. Then we have the question of future methane emissions reductions. Now, back in 2019, when DOE and National Energy Technology Lab did their last report on the life cycle analysis of greenhouse gases in LNG, basically nothing was happening. It was the middle of the Trump administration, no new regulations. But now, in the last year, and especially since the beginning of the year, there has been a flood of new regulations on both sides of the Atlantic. There's the US EPA Quad O, B, and C regulations, the waste emission charge, which is the famous methane fee that's part of the Inflation Reduction Act. There's new Canadian rules. There's subnational rules in both Canadian provinces and US states. The European Union, after quite a lot of deliberation, has come up with their own special methane legislation. It was just published in the official journal of the European Union just 2 weeks ago, although it's been sort of finalized for most of the year. So a lot of new regulations to deal with. There's the methane global warming potential multiplier. Are we going to use GWP 20 or are we going to use GWP 100? Hey, that's a question for you. And then finally, there's this knotty problem of the GHG intensity energy denominator. Are we going to use the electrical output in the denominator as on the left, or are we going to want to use the thermal input of energy in the denominator as on the right? The interesting part of this is that if you use the electrical denominator, it amplifies the GHG intensity associated with coal. Okay, because the efficiency of power plants that burn coal is quite a bit lower than the efficiency of power plants that burn natural gas. On the other hand, if you use the thermal input denominator, this does not amplify the GHG intensity associated with coal. It's a subtlety, but it actually plays a fairly significant part in this whole story. Okay, so what are the results here? So with respect to current methane emissions, NETL back in 2019 came up with 1.2% upstream loss. And okay, I've got a room full of experts there watching. This number looks low to me. Howarth came up with 4.6, which might be a little on the high side, but it's somewhere in the middle, maybe closer to Howarth. As far as future methane emissions are concerned, well, it wasn't an option in 2019. Europe hadn't started thinking about it, and the Trump administration sure wasn't doing any methane emission reductions, so not an issue. Now it really is a big issue. And if you don't consider it, and Howarth did not consider possible future emission reductions, that favors coal. Let's look at the methane GWP multiplier. Methane mostly affects the liquefied natural gas chain. There is, as Howarth points out, there is some from Chinese coal, but much less um, per BTU per megajoule. So uh, that's important. There's the greenhouse gas intensity energy denominator. NETL used the electrical version, which favors gas. Howarth used the thermal version, which favors coal. Overall, NETL, every parameter pick that NETL made favored gas, and every parameter pick that Howarth made favored coal. Now, what I wrote in my report, which is in preprint form, as referenced below, I believe these choices reflect the best judgments of the respective authors and were not driven by a desire to come to any predetermined conclusion. And that is all I'm saying on that subject. Moving on. The final issue, which I think is the most important, is what methodology are you using? Both these groups, NETL and Howarth, both use the global warming potential CO2 equivalent methodology. And in fact, the papers that have been coming out on life cycle assessment recently by our very reputable colleagues like Debbie Gordon and Arvind Ravikumar and Sarah Jordan and others all use this methodology of GWP with CO2 equivalent to get those bars that they're adding up on the chart that I showed you in slide 1. Let's think about that more carefully, because there is a consensus among climate scientists that global warming potentials and CO2 equivalents are misleading. Now, I gave a meta talk several years ago on this subject, which was a little on the abstract side with lots and lots of physics and equations. But now we've got a case where it is really making a real world difference. So let's revisit it. So let's consider what the people who devised the global warming potential and CO2 equivalents said in the first assessment report of the Intergovernmental Panel on Climate Change, which came out in 1990. I'm going to read this. It must be stressed there is no universally accepted methodology for combining all the relevant factors into a single global warming potential for greenhouse gas emissions. In fact, there may be no single approach that will represent all the needs of policymakers. A simple approach has been adopted here to illustrate the difficulties inherent in the concept. Now, 19 years later, in 2009, Keith Shine, who was the convening lead author of that chapter in the first assessment report, wrote a retrospective that was published in Climatic Change. And here's what he said in that retrospective. Did something go wrong here? How did a simple approach, which was adopted to illustrate difficulties, become established in a major piece of environmental legislation where it had the potential to influence big investment and policy decisions? Shine goes out to point that there is a lack of specificity in what aspect of climate change GWP actually represents. This has been a point of controversy for like 35 years. People actually don't know what GWP is all about. I mean, and I'm talking about the climate scientists who are the professionals in this field. There's lots of quotes like this in the literature. I'm just going to give you one more because this is a good one from Jan Fuglsvet, who published in Geophysical Research Letters back in 2000. He said, there's no single scaling factor that can convert between CO2 and CH4 emissions. The applications of GWPs does not give equivalence, and hence the concept of CO2 equivalence is misleading. As the GWP concept is currently formulated and applied, it is associated with significant shortcomings. Given the centrality of the GWP methodology in the current climate regime, it is important to communicate these shortcomings to policymakers, which I can tell you it has not. Policymakers have not gotten that message. Unfortunately, they are not readers of geophysical research letters or climatic change. So what are we to do? What measurement should we be looking at that is meaningful? Well, let's see what the Paris Agreement said. Right at the top of the Paris Agreement, Article 2, Section 1A, the fundamental measure of climate change is, quote, the increase in global average temperature. That is something climate scientists understand. They don't understand global warming potential, but they sure do understand global average temperature. So let's have a look at that. Okay. So there are a number of ways of calculating global average temperature at various levels of sophistication. I am not a sophisticated climate scientist. I did not use a general circulation model. It's kind of beyond me. What I did do was I went back to the fifth assessment report of the IPCC and used the analytic equations that they present as a pretty good approximation that incorporates all the most important physics. I'm a physicist, so I was comfortable with that. So I looked at 7 cases. And for a test case, I imagined 1,000 terawatt hour per year electric power industry. So this is about the size of the Indian electric power industry. So it's big, but it's not the whole world. And the model here is what is the addition of this industry going to do to global average temperature? So 0 is before the industry gets started up, and then it's going to run for 50 years, and it's going to get turned off because hopefully 50 years from now we'll have better solutions than burning coal, for God's sake, and then see what happens in the rest of the century. So let's look at coal first. So as you burn coal, the carbon dioxide that's emitted accumulates in the atmosphere steadily, and so the global average temperature goes up steadily, linear increase with time, as long as you have a constant power output, 1,000 terawatt hours. When you turn off the industry, temperature continues to rise a bit at a slower rate because there's an equilibration between the atmosphere and the oceans, and which is taken into account in the equations, as it should be. There's a thermal lag in the Earth. Then the temperature starts going down very slowly over a period of centuries as the carbon dioxide is slowly dissolved into the ocean and is taken out of the climate system. So we all know once carbon dioxide's in the atmosphere, it stays in the atmosphere. It's kind of like the forever chemical of the atmosphere. I mean, not literally, but centuries, right? Okay. Second case, let's look at natural gas powering this electric power industry, but with no methane leaks. So that's the red line at the bottom. It has the same shape as the black line at the top, except there's a factor of 0.4, which takes into account the much lower CO2 emission in the power plant and the fact that gas burning power plants are more efficient than coal burning power plants. When you take those 2 factors into account, you get a factor of 0.4, and that red line is exactly 0.4 times the black line. Okay, the other colored lines are natural gas with methane leaks from 1% to 5% as shown in the legend. So, methane is a powerful greenhouse gas. We have been telling the world this for 10 years. And the people on this call have been the ones who have been doing the telling. So, what happens is that for high leak rate, the temperature increases faster than if there were no leaks, of course, but in kind of a sublinear fashion, because as the power plant is putting out as methane is getting into the atmosphere associated with the power plant operation, it's also being depleted because of the 12-year decay time in the atmosphere. So that means that the increase in temperature is sublinear in time. Okay. And then after you turn off the industry at year 50, the methane effect on climate goes away pretty fast. I mean, in a few decades, it's kind of gone and has gone back to that baseline of no leaks. So this is important information that you're not getting from those bar charts with the colored bars. There's nothing in the colored bars that shows this behavior. But this is what actually is going to happen if you use coal or natural gas. Conclusion, NETL and Howarth, who came up with exactly opposite conclusions, are both wrong. They are both wrong. And what we need are physics-based climate models. Okay, recommendations. Methane emission data. This is one you'll all like. Life cycle analysts are well advised to take full advantage of technical advances in remote sensing and continuous monitoring, and regulators should encourage their use. I don't think I'm going to get any objection to this from this audience. Legislation and regulation. Foreseeable effects of legislation and regulation should be included in life cycle assessments, along with caveats that actual consequences of government actions are not always predictable. Sad but true, or maybe that's good. Methane emission intensity denominator. The thermal version of the methane emission intensity is more generally representative because not all the natural gas we export goes to power plants. In fact, the gas that's exported to China is used about half for electric power and about half for industrial, commercial, and residential heat. So there's no point using, you shouldn't use a power plant thermal emission intensity if you're going to be burning this thing for heat. So if you're only going to use one of these, I recommend using the thermal version like Howarth does. Methane versus carbon dioxide. While the current focus on methane is laudable, it's something everybody on this call has been working on hard for the last 10 years. Analysts should keep in mind that carbon dioxide is the greater long-term threat to climate stability. I'm about to start advocating for more attention being paid to carbon dioxide now that everyone can spell and pronounce methane. No economic analysis. DOE needs to determine whether exported LNG will displace coal or whether it'll displace renewable and decarbonized sources of energy in target markets. None of these life cycle assessments have really looked seriously at the renewable sources of energy. And we need to do a serious analysis at DOE level, country by country, among the importers, about what is going to happen if we export LNG to them. GWP methodology. The problems of global warming potential and carbon dioxide equivalent methodology are well known in the climate science community. Elimination of this unphysical and misleading method is long past due. Research reports and life cycle analyses invoking global warming potential or carbon dioxide equivalents should no longer be accepted for publication. So don't make me a review on your GWP paper, because I'm taking a hard line on that. Superior methodology. General circulation models and similar methods are complex but meticulously curated by climate scientists. We all know this. Given the economic and environmental stakes at risk, there is no sense to assess policy alternatives using naive back-of-the-envelope metrics like GWP. The importance of the legally mandated public interest determination fully justifies the use of general circulation models in life cycle analyses, followed by formal integrated assessment modeling. For details, I have a preprint posted on Earth Archive, paper 6912. I refer that to you for further details. And with that, I'll just close out here. and looking forward to your questions and discussion. Thanks very much.
Thanks, Bob.